Hey, how's it going, guys? So here we are back again. I am still working on a Python backend stacks playground. I haven't posted in a while. I've just been hot and heavy on the Open-FDD project, and eventually, I think some of these concepts will apply to the Python backend stacks playground. But I might make just a couple of series of videos, just kind of demonstrating where Open-FDD is at. And then talk a little bit of technical things behind the scenes. Um, because I have a feeling it might go kind of dormant, which it is kind of a good thing, because there's been some like really rapid development, and things kind of need to settle out and kind of get stable. So I'll be patching things always along the way. But yeah, this is like just today's topic. Maybe the next couple topics actually will just be the Niagara integration through WebSockets. So hoping to do a deeper dive into WebSockets today, and then soon we'll get into doing a little bit of fault detection on a real live building, and kind of getting into the whole purpose of this is like I like to look at it through a lens of retro commissioning and how to make reports on how well the existing building is operating. So yeah, let's get into it. So today's just a deep dive into WebSockets, and um, a new kind of topic for me. I don't really know much about the WebSockets protocol, and I know a little bit about BACnet, a little bit about RESTful APIs with JSON, but WebSockets is kind of a new thing, so kind of bear with me. If you don't want to learn about WebSockets and go into a really deep technical dive on this specific topic, feel free to sign off, and I'll catch you on the next round. So, okay, so just to start with, we will get back into the Python backend stacks playground, more than likely getting deep into Rust. So this is like something that um, planned even for OpenFDD is to convert some of the code base. It's all written in Python to Rust, which is more of a systems level programming language. So Python is more a scripting language. And people do use it for web applications, for the backend, but Rust is more of like a, Python is really good at prototyping, and Rust is a compiled language more for systems programming, lower in the stack, and is kind of popular to prototype in Python and then convert it to Rust eventually. Some frameworks stay in Python forever, but Rust is like, yeah, I think it's just more general purpose. People prototype and then convert it into C++. They usually do something like that. So OpenFDD has some plans to do some conversions to Rust over time. Not anything in the immediate future, but I think, yeah, we'll start diving into the Rusty backnet stack, which is made by Justin. And it's also something that's pretty new. It's even on PyPy. So yeah, let's has Python bindings. So this looks really familiar to what we were doing with backpipes under the hood. This is Python right here, but it actually Python is only like a thin little layer, um, and then Rust, compiled Rust binaries are underneath of this, kind of making everything run. Where backpipes is pure Python. It's a scripting language that's compiled at runtime, where Rust is it's a compiled language by default, so it runs a lot faster and more efficiently. And then it still has a Python API, which is kind of cool. So maybe we can play around with this, and then eventually we'll get into exclusively just using Rust. This is coming. It's like something on my to-do list. I just haven't got there yet. So yeah, Rust, it's just the syntax looks a little bit different. It almost kind of reminds me the little bit I know of C++, which is not much. It kind of reminds me of like how C++ looks. Um, but yeah, so like we'll get into this in time. Um, anyone also interested in, yeah, so this is made by Justin. Anyone interested in, just hopping on a Discord channel, learning a little bit more about it, just go to the Python Backness X Playground and join the Discord channel, um, which is actually Open-FDD's Discord channel, but there is some places for Python, Niagara framework, HVAC and mechanical chats, embedded system chat, software engineering chat, artificial intelligence chat, and Justin right there. And chat about anything. And I constantly post um, YouTube videos, just kind of keeping up to date with like what's going on with artificial intelligence. So there's like yeah, lots of good stuff here. And then um, even if people have building automation help or ideas, or if you're into tinkering around with coding things yourself, or IoT people, um, join the Discord channel. Lots of friendly faces on there. Okay, so like what I wanted to get into today was this is someone actually from the Discord channel. Um, his name is Rob. I think his name is Ben, but goes by his middle name Rob. I'm just gonna go by Rob. Created this pretty cool package on GitHub. So this is a compiled module for the Niagara framework. A jar file, which is that's a compiled Java file. Um, so kind of more like Rust, I guess. Java is a compiled language. It's not like Python, where it's a scripting language that's compiled at runtime. Like when you do things in Java, you compile it into a machine level code. So it's a .jar file. Niagara, people familiar with the Niagara framework are very familiar with jar files. Something we do all the time. So it looks like he's making some Grafana interfaces and everything like that. So like this is the so Backstream is a Niagara 4 runtime module that exposes the station data through authenticated WebSockets. Pretty cool. So mostly written in Java, a teeny bit of Python. That was me. I added in some tools, how to play around with Python with this. And yeah, so there's a pretty cool diet. Ooh, and even a model context server protocol. So basically, you just drop this jar file into Niagara framework, just the same way you do it with everything else. Um, and then it exposes this station as a service, and then you can interact with it through WebSockets protocol, which I'm kind of interested in learning a little bit more about that. Oh, cool. So got the Python tools. So the Python tools is how I made the drivers for Open-FDD. I should say that um, AI agents made the drivers for Open-FDD after creating some really basic scripts, like the Python Backness X Playground. As soon as we create some scripts, we play around with it, and then you can kind of pass it off to AI to like make a driver out of this. So that's what I did. So here we go, Grafana, cool. Maybe we'll play around with that someday. So Haystack protocol is another one you can play around with too. That's been around for a long time. So Haystack is like a RESTful API protocol, and then a little bit different than WebSockets. I think it's really similar though, because WebSockets, to my knowledge, is a TCP based language, where BACnet is a UDP language. I think BACnet Secure Connect is a combination of WebSockets and BACnet protocol. So yeah, let's kind of dive into this. So basically, I downloaded this jar file. I have Workbench running on this Windows computer right here. And then it's hopefully you guys can see this. I think this is as big as I can zoom in on Workbench here, but this is just typical station right here. I'm running 4.13 Niagara 4 version 4.13. And then when you drop the module in, you can pull from the palette a BASC stream, um, BAS stream widget out of the palette, which is the compiled jar file. And then, this is really common to how you do things in the Niagara framework. The Tritium people will be really familiar with this. And there's a couple little things here. There's like this web service paths, I guess. This is a route. So like Tritium is the Niagara station here is a web app. And I'm just using this little tool here as like a desktop application. That's what Workbench is, but there's also a web app running behind the scenes. And it's exposing authenticated web sockets to the Niagara framework. I did also, when I was playing around with this locally, this is also in the documentation online, that I did do this allowed origins for local hosts if that's needed or not. I'm not quite sure. But on my test bench here, I have a BACnet driver, and I have one BACnet device. So I have a JCI FEC just on a little test bench here, just a really old device that just happens to be functioning still. That's good enough for a test bench. And there are some points pulled into it through it too. So this is my backend application, my station running on Windows, same computer I'm recording this YouTube video for, which is just for development purposes to play around with WebSockets and build a driver for it. Okay, so hopefully that makes sense. So I've been making these charts the last couple of videos. So I am just on my Windows computer right here. And then through, actually, this will be, I'm not even using an A cursor on this one. I'm just using VS Code because this is on a Raspberry Pi on my test bench. I want to run some experiments here with WebSockets and learn a little bit more about it because I don't really know much about it. So I just have a really old Raspberry Pi just on my test bench right next to me. And this is this JCI FEC down here, actually. So it actually talks to a BACnet router, which converts it from BACnet MSTP to BACnet IP, which will then talk to the Raspberry Pi. And then it's also talking to Workbench running here through BACnet. Yeah, so nothing is going out on the internet through a firewall or anything like that. So just all local hosts. Okay, so where should we go with this? Yeah, so thanks, Rob, for creating this. This is pretty cool. I think this, from my research, this might even be more efficient if this is a really, like what I imagine using this for would be a really big Niagara site where your Workbench tool would have, this would be a Niagara server station, and you could have hundreds of buildings, hundreds of points, all lined up here. And then what I want to see is like one Open-FDD instance, like pulling in all that data, running fault detection across it. Cool. So enough about that. I think this is the company that Rob works for. It's called Q&A Graphics. So they actually do basically custom graphics for building automation systems. So like when you get a building automation system, they're usually like very junky, clunky, something that looks from the 1990s. And then Q&A Graphics is a company that builds custom 3D like rendered graphics, basically. It's not the word I'm trying to use for it. Like you can't get anything this detailed right from Workbench. It comes with some really piddly looking widgets from 1990s ish, but this is what Q&A Graphics does, is they make some like really cool turnkey job stuff. To my knowledge, I think when I was part of a Tritium startup group, I think that we use Q&A Graphics to like I could have swore this is pushing 10 years that I could send them a backup of a Niagara. So when I was in the field commissioning, I could just go back up, and then this should be a zipped file of a station, and then I could send this to Q&A Graphics, and then they would do all of the graphics for me, and then they would send me the backup file back to me of the Niagara station, and then it would have all the graphics preloaded and everything like that. It worked out really slick from what I remember. Um, Looks like they're still in the business for that. Okay, so what I did is like I asked ChatGPT to make me a tutorial on WebSockets. So like maybe this will go into a couple days. Just getting through this, but I think I want to do like a good, daily video on Open-FDD in general. So I think there's just so much ground to cover here. Why not start with here? And then, so these days you can just feed into AI links directly and it can research the tool itself. So I asked it to make a kick butt tutorial on WebSockets. I told it I understand REST API, but not so much about WebSockets. And I told you it would be really cool how to mimic a Niagara station just through maybe a Python web app that we can whip up for learning purposes that would mimic a JACE in a station, maybe even take some packet captures of WebSockets. So, which eventually we need to do anyways when we get into the Rust backnet stack. I want to use AI to start converting Python backnet stacks to Rust, and then kind of validating it that there's no errors, there's data, good data like this, and then also through packet captures. And then I'll just let AI I iterate until needed to convert code bases from one to the other because they're really efficient at doing that. I even have it planned out to do this for Open-FDD in time, but that's kind of a huge can of worms that we might do little by little. But I think in time, I want to learn a little bit more about WebSockets and Rust in general. And then we can just kind of start sketching this over. Okay, so let's read this. Part 1, REST versus WebSockets, HVAC guy explanation. All right. Open-FDD asks for an API, let's say outside air temperature, and it gets a value back. So this is like JSON, which Open-FDD has a JSON API for it as well. So what you can use this for is OpenWeatherMap API. You can get, this is free data that I'm getting from OpenWeatherMap to start logging. I'll show this on the live site, but I'm logging outside air temperature from OpenWeatherMap, dry bulb, relative humidity, and then just a description, I guess. And then I'm going to write a rule that compares the local flimsy building automation system to the web weather, which should, in theory, be a higher quality outside air temperature sensor installed at like an airport weather station. And then I can write a rule that the flimsy, crappy local building automation sensor needs to be within a tolerance, let's say a degree up and down, of the web weather, airport weather station data. So we'll get into that. That's coming when we get into fault detection rules, but JSON API. So like the OpenFDD has a JSON API, which will maybe just be a day or two playing around with it. Okay, so where were we? So we were in Niagara still. Okay, so what's the web Okay, so that's JSON, that's the API value. WebSockets. So uh, if you see like there's a get, so a get in web apps, the backend, there's REST APIs called a get and a post. Um, a get is a very frequent one, and a post. So get is like I want information, and sometimes in a post you post a little bit of data in the body of an HTTP call, and you post it to something in JSON. So like WebSockets now, if there's a web URL, not any different than this, WebSockets, and then the stream is the supposedly. So now the connection stays open. Okay, so that makes sense. So I think like REST API is a little bit like ping pong, like ping you. There's a ball, a packet that's going back and forth. Like I think they call it RESTful API is uh, it's either stateful or stateless. Like there's always like processing, confirmation, ping pong. I can't remember which one, if it's stateful or stateless. And then backnet is more like a machine gun. It's just firing data and firing data back. But yeah, hope that makes sense. So I think like this is more like WebSockets is a continuous stream of data, which I think is more closer to like what BACnet and UDP would be like. Okay, so without Open-FDD asking, like leaving a radio channel open, tell me whenever the outside or temperature changes. So this is much better for graphics, alarms, fault detection, trending, blah, blah, blah. Cool. Okay. So, gosh, so this makes me think, because I set up Open-FDD for polling, whatever. Like we can get into that. So I think like what Rob from Q&A Graphics is doing, it's really good for graphics, building custom cool HTML graphics. And I think it's really common in web apps that WebSockets would be used for something that needs constant changing. There's constant data exchange. Part 2, what Basque Stream is doing at a high level, Niagara Station, Niagara API, RESTful API, and then there's a service for WebSockets and then OpenFDD. So instead of OpenFDD polling, Backstream pushes. Okay. This is why the Niagara sites with 5,000 plus points become much more practical. What happens on the wire is apparently there's a get stream WebSockets connection up, whatever that means. Server replies switching protocols. HTTP is gone. Okay. You have a persistent TCP connection. Data becomes frames containing JSON payloads. Cool. Part 4, Windows packet capture, Niagara side. Oh yeah, okay, so we're gonna do some Wireshark, because I'll get that fired up. Hopefully this doesn't need any updating. Okay, so we can start a packet capture right here in Windows. So this is saying like I can just start a packet capture, and then Wireshark is something I'm not very strong in, so bear with me here. So filter the IP address. All right, so let's try this. So this is Wireshark. I wonder if I can zoom in here. Wonder if this would be a good place to stop. View, full screen, zoom. Doesn't look like I can zoom in. Control++. Well, sorry guys, it doesn't look like I can zoom in here. So, okay, so let's start capturing some data here. Assume that I'm capturing data here on Wireshark. I've actually only recorded, I've only viewed packet captures taken on Linux with TCP dump. And I've never actually, haven't done this recently, where I've just recorded right through Wireshark. So this has been a little while. Let's see if this is even, no packets captured, no data. Okay, so like, I think I might need to switch to, oh, here we go. Ethernet, so where are we here? I think I just need to go, let's just see which one we need to select here. Where'd this go? In PowerShell, if I do IP config, IP config, you must have to select. So what I want to do is select Ethernet adapter 1. No, it's technically this guy, because I can tell that this is my local area network for BACnet. So adapter for Ethernet, I guess it would just be this guy. Okay, so I think I can do this, and then I can start capturing data. I think I'm capturing data. So wow. Okay, so some SSH data, TCP. I'm getting way out of my comfort zone. I haven't. Ooh, there's BACnet. I have not played around in here in a while, so it's actually been years. Okay, so let's just do. Let's try this. Nothing. So we just have to use the port that. Maybe I'll just have to research this. Okay, so we'll also play around with taking packet captures in Linux. What else is in this tutorial? Best 5-minute packet capture. Start the packet capture, change a point in Niagara manually. Okay, so we'll have to read this. I think I need to do some research on what port that the WebSockets are running on. Okay, so if I go in here, maybe we can figure this out. And we could even hop right on Discord. This is what Discord is for. Do at Rob. What TCP port does what TCP port does the BAS stream. Looks like there's lots of cool stuff going on here. Whoops, wrong button. Okay, so maybe Rob will answer us while we're on here. Because I don't know. I'm actually trying to learn this. So maybe it says here. Maybe we'll just have to research this. I can't remember. So if we go back here, GitHub, Bask stream. Nothing like learning. So, okay. So where do we see? All right. Looks like there's a way that you have to sign your jar file. I don't even know if I did that, but there's probably coming up for Niagara 5. You can also write. I think you can discover the station, which is cool. Anyways, it looks like I might need to do some homework here. Oh, here we go. So port 8787. Just to see what. Nothing. I feel like there should be stuff on here, so. I don't know if this works. Nope, doesn't like that. Maybe I'll have to do a little bit more homework before coming back and recording some YouTube videos. So yeah, this is pretty cool though. I need to yeah, you can even read history. So, and also schedules. So that's pretty powerful too for people doing optimal start. So yeah, there's subscribe. So pretty cool. And maybe that's what we should be doing. Okay, so let me think here. So like when we're here on, so this is the UI for Open-FDD. So like what I'm attempting to build is just to get more familiar with how this works. So, but I do have something working already, so I can even refresh values in Open-FDD, and like what it's doing under the hood here is just is the Linux computer running Open-FDD on my test bench is actually requesting data over WebSockets to this Windows computer. And I think it's kind of important just to get a little bit more deep into the weeds of how WebSockets works. So let me just get into let's just try this. I'll just do this here. Well, maybe hold up. Maybe I'll just give AI just the URL. Could do that too. And I'm just gonna say I cannot figure out how to view WebSocket traffic in Wireshark. It's not working. Whoops, sorry guys. Let's see. So where should we go with this? I'm just gonna say TCP port 8787 is it's not showing anything. It's not showing anything, but there is lots of Wireshark traffic. Lots of SSH stuff. So maybe I could even, let me just see if I can browse by IP address. So think WebSockets would be running on, hold up, let me just, where did it say? I have to get the little cheat sheet here on IP address. What if I could just do this? So like the IP address of the machine requesting polling data would be 14.18, I think. Wait, it would just be this. This would be 204.18. 204.18. Okay, so here's lots of SSH, encrypted packet. I just like stop this and then just okay, so I stopped the live capture, and then let's just scroll through here, and I think that I don't want SSH, I want the TCP encrypted packet. I think it's these guys. So maybe I'll just screenshot this. Dump this into ChatGPT, and then just say this is Open-FDD running remotely on that URL. And then, hold on, I should do this again too. IP config, and then the station, copy this. And the station is running on that good data, where then WebSockets would be in between. Okay, so this is all I know about how to use Wireshark. I'm not very good at doing Wireshark, but there's no better time than to learn. So it's saying to look for that. Verify in Chrome. I don't think ChatGPT is giving me good information here. So that's what I did. I did that, sort by bytes. All right, none of this looks very useful to me, but let's just see if we can drill through here. Anything in here of interesting? So this is like where data is getting sent between the this is Open-FDD, and then this is the Windows machine. SSH protocol. See if I can just do this. this. That's SSH. So I don't think we want SSH. I think we just want plain TCP. And I'm just not used to looking at this very much. No, that's your SSH session. Yes. Use this to filter or hide. Okay. Get out of these and then put this up in the top bar to filter. All right. Ooh, look at this. So there is HTTP JSON, HTTP JSON. Maybe this is part of it. So I'm just going to tell ChatGPT is the screenshot, is it the JSON? Let's take another screenshot. I'm sure anyone that's like a networking expert is probably laughing right now, but I just don't get to play around in here that much. But I think like if I'm doing like development work, I need to get more comfortable with using this kind of work. JavaScript. Well, this copy all visible items. All right, so we'll probably wrap up this video kind of soon. Maybe it would be fun just to see like what a value of temperature sensor over WebSockets would kind of look like. Ooh, actually, I think it's supposed to look like this. TLS. Client hello, server hello. Not using TLS though, so yes, this is useful. This is definitely REST API traffic. Okay. Okay, so this is actually the username of Open-FDD. So it's the authentication. So let's see. Oh, this looks super useful. If I could do this. See if ChatGPT can give me a little cheat here to filter some data. I thought this would be a lot easier. I just don't see much WebSocket stuff. All right, guys, I think I probably should just stop here, and then I'll just have to do some more homework on how to view how to do packet capture in WebSockets, because it's definitely working on getting the data from the station and then monitoring it in OpenFDD. I just want to do a little bit deeper dive under the hood and then just get more familiar with this, because we'll be using Wireshark quite a bit in the future. So if you want to join me for this ride, I feel confident that now it's the time to learn it. I've been meaning to learn Wireshark a little bit deeper along the way anyways, and maybe this is just a good place to start. So sorry if this video is kind of a little bit daunting and it's kind of like a wild ride, but let's you got to start somewhere, right? So, and maybe I'll post a video tomorrow. So I'll get this working, and then I will do a little bit of a deeper dive on how to actually filter and find the value of like a temperature sensor or something in Wireshark, because I know I can do it for BACnet, and if I can do it for BACnet, I know I can do it for WebSockets. So thanks for following along. Sorry if there's a little bit of a failure mode here, but I think we have to start somewhere, and see you on the next one.